Pepsi and sour green apple. That was a phenomenal Slurpee. Okay, so now that you've all gotten your stuff out, what is a technique someone willing to volunteer that they used to solve this problem? Pavneet.
I pulled out the long division on the fraction.
Seriously, you pulled out long division to convert them all to decimals? Okay, you are a... I'm not going to go so far as to call you a psychopath, but a masochist.
Okay, don't worry.
You know?
People have called me that.
No, I would never say that about a student. No, but that's bold. You long divided all 4 of those fractions.
Oh, no, not all, because I already know what 1 over 2.
Okay, so you said 1 over 2. So you're doing some decimal conversions of things you know.
Yeah, and I already knew 4 over 9.
1 over 2 is?
0.5.
0.5. 4 over 9 is?
Wait, let me think. I forgot.
The 9th.
0.4.
It's not 0.
4.
Okay, my dang, and you rush. It's 0.4 repeating.
Yeah.
So 4, 4, 4, and then I'll put the line over top of it. Cool. So some of the ones are they're just coming off of the page for the stuff that I gave you before. That's cool. What are some other ones here that we... No. So did everyone do the decimal conversion, or did anyone do common denominators for the fractions? Common denominators would be pretty terrible because you're doing common denominator of 2, 3, 5, and 9. The common denominator of 2, 3, 5, and 9 would be 90.
Oh.
90? Yeah, 90. That would be awful, but you could do it. So did everyone who did the homework, the one question I gave you for homework, convert to decimals? Okay. So then negative 2/5 is going to be what?
I kind of just wrote them down as fractions instead of decimals, so I kind of have...
Okay, so you left negative 2/5 as a fraction?
Yeah, I left it as a fraction, but I kind of figured out where it would go.
Okay, well, that's fine. We can talk about that. And then 1 2/3. What'd you do with 1 2/3? Did you leave it as 1 and 2?
I got 1.66.
So that one you turned into a decimal, okay?
Yeah.
Okay, so that's 1.66 repeating.
Yeah.
So, hold on. I just want to make sure I understood everything properly. So these 3, you converted to decimals. You left this one alone.
No, like on the number line?
No, just at this stage. Yes, I know you wrote the note. We're going to get there. I just want to make sure I'm understanding your steps as we go. You left this one alone. And obviously, these are whole numbers, so you can just leave them be. Okay, so then did you order them first, or did you number line them next? Like, after you did these conversions, what did you do next?
What did I do?
Yeah.
After I did the conversions, I just set them down on the first number line that you told us.
Okay, so you ordered them first.
Yeah.
Okay, so your least, and you went least to greatest. So what's your least value?
This value is -1.
Okay. Gentleman over here. Who's talking? Good, Tess and Carson. Shh.
Oh, you want a pencil?
You need if you need a pencil, there are pencils up by the printer. Okay, so you did -1. Then what's next?
-2 over 5, which I got 0.4, and then repeating
Oh,
0 is 4.
It's the only ever need with the zeros you don't need. So negative 2/5. So you did turn it into a decimal.
Yeah, I did turn it into a decimal. I just wrote it down here, and I just realized that I
Negative 0.4. Okay, so then the next one would be, it's the only other -1, and it's closer to 0 because it's a smaller number, which means it's less negative.
Yeah.
Cool. So that's that guy and that guy, which, again, when you're actually giving it to me as an answer, I want you to use the original values that were placed. So that would be the negative 2/5.
Yeah.
Your next value was?
4 over 9.
4 over 9.
And then 1 over 2.
And then 1 over 2, because you're just going in order now, because the 4 over 9 is going to be the 0.44 repeating. So it's your first, it's the smallest positive one. And then that's your 0.5, okay, which would be bigger than 0.4 repeating. And then 1 and 2 over 3. Cool.
And then 2.
And then 2. Don't want to forget the 2. So then when you're putting these on the number line, it's this guy, that guy, that guy, that guy, and that guy that we're putting on the number line. We just use the decimals to approximate them, not to approximate them, but to give us a way to think through them. So then when you made your number line, Pavni, how did you, it's unlabeled, so what did you do? It's an unlabeled number line. So how did you place these values on the number line?
I put 0 as a placeholder.
Right where?
Right there.
Right in the middle?
Yeah.
Like on one of the...
Exactly in the middle since it's
Like-
even, so I kind
Okay, so you put 0 right there.
Yeah.
And then,
For the fractions, I put them.
hold on. Did you go up by ones then? It was that 1 and then 2 and then that's -1?
Yeah.
Okay. Did anyone, when you're making your... Okay, Isabella, or Annabella and Geronimo. Shh. I have an Isabella who sits right there in a different class, so if I call you Isabella, I apologize. If you... Did anyone not just call this one 1 and this one 2? Did anyone use different values for their number line? Or did we just go up by whole numbers on the number line? Hands up if you went by whole numbers on the number line. Hands up if you went by something else. I'm not going to ask for hands up for all of you who didn't do the homework. Okay, so, and then you called this one 1, that one's 2, that one's -1. So you're not using the number line to its fullest potential, but this is a sufficient amount of number line to use. I mean, we could have gone more than that. I'll show you what I did in a second here. So so that's 0. How did you place things on the number line?
I kind of just shoved the fractions in between.
Okay, so let's go in order. -1's right here. You want a -1 on the number line? There it is. So the -2/5 is where?
-2/5 would be in between 0 and -1.
How far between 0 and -1? Like closer to the -1, closer to the 0, right in the middle? Like where did you put it?
I put it closer to the -1, but not really. Like a little to the left of the middle.
Okay, is that the right place for it?
I got point.
This is -0.4. Is -0.4. What is halfway between 0 and -1?
Oh wait, no, I put it at 1.6.
Yeah, see, this is exactly the mistake that we talked about yesterday. This is where I said, where did we do it? Right here. This is where I said, this is why we talked about -0.8 and -0.2. It matters where, and you guys were like, oh, yeah, yesterday. Because it matters where you place these things. -0.2 is closer to 0 than it is to -1, and so you want to put it closer to the 0. -0.4 isn't yet halfway. Yeah. So you did yours differently? Like you labeled these differently? Okay, I want to see yours in a second. So, Pavni, where should -2/5 be in between 0 and -1?
On the right of where 0.
So, so halfway would be -1/2, less than that. Cool. So you're going to be over here somewhere for your -2/5. Cool. 4/9 is going to go where?
The left of the middle after 0.
To the left of the middle after 0. Okay. So it's going to be, you're moving from 0 towards 1. You're almost at halfway, but you're not quite yet. So those are going to be your 4/9. Right in the middle is going to be your half. Oops, nope. Half. Your 1 2/3 is going to be where?
Closer to the 2.
In between the 1 and the 2, closer to the 2. So there's your 1 2/3. And then there's 2 right there. Fantastic. Tanveen, how did you do yours? How did you scale it? So what I'm hearing you say is how I did it. Like something that looks like this. So you said 0 was in the middle-ish somewhere, and to use up more space, you went up by 0.2s. So there's my 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.82. And then -0.2, -0.4, -0.6, -0.8, -1. I should have done the fractiony things here, and I didn't. There's my -2/5. There's my -1. There's my 4/9. There's my half. My 1 2/3. You betcha. So how Tanveen did it is how I did it. There's my -1 and my 2. When you've got as much space as you do on a number line, you don't have to call everything 1 and cram it into such a tiny space. You can spread yourself out. You've got lots of space here. 0 can go kind of in the middle, and then you can start to move out there. We don't have enough to go up by 0.1, because that would take us to 1 right here. But going up by 0.2s is a good way to do it. 0.2, and then those are those blue numbers there, and then the green ones that I just added would be the numbers that you'd place in there in order. Did anyone do it differently somehow? You could have gone up by 0.5. It's like 0.51, 1.52. Even anything is less cramped than going up by ones. But again, there's nothing wrong about this. You just need to make sure that what you've chosen to do is very clear. Questions, comments, concerns on any or all of this? Cool. If all of a sudden you do, let me know. Okay, find me this page. We're going to finish the conversions of stuff and the comparing of things. And I just want to draw your attention to the schedule. I'm just going to toss it on the screen for funsies. No reason in particular why I'm putting this on the screen. No reason. No reason.
Oh, no.
No reason.
I'm agreeing with you. I said totally.
No reason. Okay, here we go. And if you... Are we confused? Because clearly I have a tone. I have a tone. Okay. I'm just going to toss that there. We're going to finish the comparing numbers lesson today.
I might want to practice a little one.
There we go. So, converting decimal numbers to fractions. Part of the comparing sizes is being able to put things... We are going to go out of fractions into decimals more fully. But there's nothing wrong with taking decimal numbers and putting them into fractions. And so, to get a handle on doing things that way, comparing fractions as if they were all fractions. So, I got this number here, 1.2345. And I want to take that number and I want to convert it into, where's my things, a fraction. How do I do that? Fortunately, it's all pre-built for us already. What place is that 2 in? What is the name of the place value? Tenths. THS. The 3 is the hundredths. So the 4 is the thousandths. So hundredths. Thousandths. So that would be the... No, 1000 is 1,000. It would be the 10,000ths. And so there really is quite a nice conversion between decimals and fractions, because this is just a fraction out. Like, I could say this as, if I read the number, 1.2345, or I could say that this is, how else could I read this? 1 and, so it's either 1 point, if I'm reading this, 2, 3, 4, 5, or I could read this number as 1 and, how would I read this? Put hyphens in here, 2, 3, 4, 5. What's the point of the place values? Mishwa, is that a hand? Sorry, I am hearing the answer. Who is that? Guntas, was that you? Was that you whispering the answer? Sounded like your voice. Mading, was that you?
Yeah.
I heard it coming from over there. Okay, 1 and 2. Oh, yeah. I only heard part of what you said. Mishwa? If this was the number, it would be 1 and 2 tenths. If it was this number, it would be 1 and 23 hundredths. Here I've got 234 thousandths. So this whole number would be 1 and... Nope. Almost. 2,345 thousandths. No, 10 thousandths. 10 thousandths is how I would read that in English. Which is why we lose some of that because your middle school teachers and your elementary school teachers, wherever you saw this the first time, don't often talk like that. But that's what that fraction means. Or this decimal means. It's 1 and, the and is the decimal point, 2,345 10,000ths. Because this is the 10,000ths place. So I could rewrite this as 1 and 2,345 over 10,000. And now I've got a fraction. Is this fraction reducible? Tanveen says yes immediately. Divisible by what? By 5. You're looking for divisibility rules. Even if it's divisible by 2. If the digits add to 3, it's divisible by 3. If it's... Ooh, I don't remember what the 4 rules are. If the last 2 digits are divisible by 4, then I think the thing's divisible by 4. But the important one here is that this ends in a 0 and this ends in a 5, so they're both divisible by 5. We could start dividing by 5s here if we wanted to. I don't want to, because this is a gross question. But this is how I want you to think about the procedure of converting these things to fractions. So here's the instructions that I've given you here. When you're converting, you want to find the decimal place of the last number that is not a 0. So that's why I went all the way over here to the 10,000ths. You put the th, the 10,000ths, as the denominator. You write all the numbers after the decimal point as the numerator, which is what I did here. If you had a whole number, it goes as the whole in the mixed number. And then simplify the fraction if required. So, why not? Let's do this. It could be terrible, but let's try it. I want to try reducing this. Let's go down here, because it might take some space. I'm going to long divide this because that's a lot. I want to divide 2,345 by 5. It goes into 23 4 times, so that's going to be 20 and 3 and a 4, so 6 is 30, and a 4, bring down the 5 is a 9, 45, 0. There's my long division. 2,345 divided by 5 is 469. So then this thing's going to become 1 and 469 over what? What is 10,000 divided by 5? Or another way to think about it, simplify it a little bit here. What's 10 divided by 5? 2. So what's 10,000 divided by 5? 2,000. And we might actually be done. Because this number is not even, but this one is. What is 469 divided by? That is not simplifiable. We are done at that point. So this number, 1.2345, would be written as 1 and 469 over 2,000 as a fraction. Why we would do something like that, I don't know. We would not do that very often. So let's do some of the simpler ones here. Let's go back to this simple example, 2 and 19 over, or 2.19. So how would I write 2.19 as a fraction? Yeah. So I could write it as 2 and not 19/20ths. 1900ths. Because this 9 is in the hundredths spot. So 2 and 19/100ths. That's a 9, not a 4. If I wanted to write that now improper, how would I do it? I would multiply the denominator, the 100, by 2, get 200 plus 19, so then this thing would become 219 over 100, bless you. 19 is prime, 100 is not divisible by 19, so yes, this cannot be simplified, so therefore this cannot be simplified. Cool. This I would have loved to have finished yesterday, but we didn't get a chance to finish it yesterday, and that's fine. What I'd like you to do, let's do one more example. Let's do that. You don't do 2 more examples. Let's do this guy. Yes. They were just always there. Okay, 0.2. What's 0.2 is we know what it should be, because we talked about it yesterday as one of the things to remember. 0.2 should be...
2 over 9.
No, that's 0.2 repeating. Yes, Guntas. No. Okay, let's do this. It's a good thing we're doing this. What place is the 2 in? It's in the tenths spot. So 0.2 is going to become 2/10. because the 2 is in the 2 is in the tenths spot. So now I can reduce this. What are 2 and 10 both divisible by? 2. Divide by 2, divide by 2. 2 divided by 2 is 1. 10 divided by 2 is? 5. No, we'll do a few more of these to get. So 0.2 is 1/5, not 4/10. Because 4/10 would be 0.4. Because there would be 4 in the tenths spot. Okay, if I had something like this, 0.200, I mean, the instructions did say find the decimal place of the last number that is not a 0. So if you followed the instructions that I've just given you, you would say, oh, the non-zero one there is a 2, so we would do the exact same thing. But if you forgot to follow instructions, and I don't know why any student would ever forget instructions, I'm sure you have never forgotten to follow instructions, but let's assume that someone has. Mr. Minochin. Mr. Minochin is not a good instruction follower. So he forgets the zeros, goes straight to the end and says, that 0 is in what spot? No, because it goes tens, then hundreds, then thousands. So this number would be 200 over 1,000. Because it's tens, tenths, hundredths, thousandths. So it would be 200 over 1,000. This is reducible. Divide them both by 10. Why not? Let me keep them simple. That's going to be 20 over 100. Divide them both by 10 again. It's going to give you 2 over 10. Divide them both by 2. That's going to give you 1 over 5. The result is the same because 0.2 and 0.200 are the same number. You should be able to do, you should be able to recognize that these two numbers are the same. And if you don't, you should be able to follow them down to the same value and then say to yourself, okay, well, they must be the same. They reduce to the same fraction. 3.4, the next one, is going to be what? How am I going to do this guy? The whole number can remain the whole. Yes, Pevney. Yes, because the 4 is in the tenths spot. So we can start there. And now what?
Reduce it
By?
by 2.
Divide both by 2. You betcha. The whole number is going to stay out front. 4 divided by 2 is 2. 10 divided by 2 is 5. So 3.4 is 3 2/5. Next one. Someone who's not Pavneet. Mishwa. 2 and 5 over 100. Very good. Because that is the second decimal place is the hundredths spot. So now we can go ahead and reduce this thing. 5 and 100 are both divisible by 5. Because if you end in a 5 or a 0, you're divisible by 5. So this is going to become 2 and 5 divided by 5 is 1. 100 divided by, 10 divided by 5 is 2. So 100 divided by 5 is 20. So 2.05 is 2 and 1/20th. Or for funsies, we could call this 41/20ths. Why you'd want to do that, I don't know. But you could. And then 3.001 is... Yes. Sure, let's go for it. I was going to call on some Mishwa again, but because you've given me a few. 3 and 1/1000th, which is not simplifiable because 1 is not divisible by anything other than 1. So you're done. Comments, questions, concerns on the procedure? If seeing none, I will start floating around. What I'd like you to do now is play. You got lots of time. Bunch of practice here for you. Actually, not even that much practice. Page 21, 22. I want you to compare the following numbers, order them from least to greatest. There's fractions, there's decimals. Do whatever conversions are necessary. Actually, I do want to be specific how I want you to do these. How do I want to do this? Number 1, let's do it this way. I want you to do, I would like 1, and I want you, oh boy, how do I want to do this? Because I want you to practice both ways. Those of you who have done it already. You're going to have to tweak some stuff here. I would like you guys to do... How do I want to play this out? I don't want to make your life too miserable. I would like you to... Yes, here we go. I would like you to do the first two questions, 1 and 2, all as fractions. And I would like you to do 3 and 4, converting all to decimals. Yeah, you got 3/5, 2. Yes, let's do it that way. Yes, because we have 3 and 4 have sevenths and ninths in them. That would be awful if I asked you to do that as fractions. I don't want you to do that as fractions. 1 and 2, I want you to demonstrate 1 and 2 converting all of those numbers into fractions and then placing them on the number line. And then 3 and 4, I want you to do all of those, converting them all into decimals and then placing them on the number line. We'll see how you do with that. If we have time, we'll move on to something else. But on your mark, it's a giver. If you worked ahead, now that I've changed the instructions, you've got some stuff to go back and tweak. Yeah, man.